Good morning, everybody, to our next session on the variables and equations problem-solving strategy. So, our next topic is a special kind of equation that comes up a whole bunch when you start looking for it. You see it is in many places. It's called a ratio equation. And what it is very simple requirement. Let's write the heading here. Well, I call it a ratio equation. To be honest, I don't really know what it's called, if it even has a name. But regardless of the variable, it doesn't matter where the variable sits. If I have a fraction on one side of the equation and a fraction on the other side, so fraction equals fraction, I'm going to call that a ratio equation. And when I convert ratios, convert exchange rates and stuff like that, ratio equation is always going to be there. So if I just look at two simple exercises with the position of the variable in different places. The first one, the variable is n for number, but it doesn't really matter what we call it, right? I have the n in the numerator of the first fraction. Now, without knowing anything about ratio equations, what do I have to do? Well, I have to multiply both sides by 4, and then I get n equal to 9 times 4 over 6. Calculate that, don't calculate it, that's not really the point. The point is I can do it. Exercise 16, where I might have the variable in a different place, like the denominator of one fraction. Doesn't really matter what side it is, I can easily flip this. So it could feature in the denominator. Now, what I have to do is a little bit more involved, I guess. Not much, a little bit more. I have to somehow get the variable out of the denominator position. So I'm going to multiply both sides by n, and then I have 3 over 8 times n equal to 21. Then I have to divide both sides by 3 over 8 to get n alone. And when I divide by a fraction, I multiply by the reciprocal, it's equivalent. So I have 21 times 8 over 3. And we did fractions before this for a reason. It's all in the videos if you need to go review. Okay, so I can do it. This second one is not very nice looking in the process. I don't really like to use a variable in this way for fancier reasons I don't want to get into now. It could get me into trouble. When it comes to ratio equations, there's actually a very nice shortcut to deliver the same result, but it'll be more consistent regardless of where the variable is. So let me just copy this equation, 9 over 6. What I'm going to do is, I need to have a fraction equals a fraction. This is only going to work for ratio equations. I'm going to take the top of one and multiply it with the bottom of the other, and the other pair as well. So I'm going to put the pair that has my variable in it, I'm going to put it on the left. So n times 6, 6 times n, and then 4 times 9, 9 times 4, it doesn't really matter, right? And then I have one more step, which is dividing by 6 to get the variable alone, and you see that I get the same result. I didn't do much. And in this case, was it necessary? No, probably not. But I'm looking for a way to simplify this equation that works regardless of where the variable sits, so I can always do the exact same thing. This should we say, cross multiplication is a way to get the same result. And it works because it works. That's pretty much it. It's not the same as fraction multiplication or anything like that. It's a new thing. So let's see if it works here as well. I'm going to multiply the top of one with the bottom of the other. And the pair with the variable I'm going to put first, because it's going to make the result nicer. 8 times 21 for the other pair. And then, of course, I have to divide by 3. And notice that, first of all, we get the same answer. So that's important. But secondly, it looks the same as the other example. That regardless of where the variable sits, what I do is consistent. And that gives me confidence. I know going in that I'm going to do one thing. It's not what makes people anxious and fearful and all kinds of things is when, sometimes I do this. If it looks like this, then I have to do that. And I have to remember all this variety. No, I want something that's plug and play. That gives me confidence at some stage that I know going in. If it's a ratio equation, I cross multiply, isolate the variable, I'm done, regardless of where it sits. Okay, so that's how I'm going to handle it. So I want to be efficient in my essentially step 3, solving the equation, so I can focus on the more important things. Not that it's not important, but setting it up and analyzing a word problem, that's much more crucial to the solving of the problem. All right, so whenever I see fraction of a fraction, I can do this cross multiplication technique. So now, all that we're going to do, you see it all on the screen. We're going to do these 5 problems. And that should hopefully give you enough exposure to ratio equations and where they could come up. And like I said, once you start looking for them, they're in many places. Now we still try and keep things fairly simple. Right? Exercise 16-17. Your car gets 23 miles to a gallon. How far can you go on 16 gallons? Now I know this is the first example, so I've made it simple on purpose, and depending on your experience, you might feel that I don't need any fancy equation for this. It's obvious, because I just drove my car a long way and this question came up and I figured it out. Well, good for you, but I have to cater to everyone. And I have to prepare myself for when things get complicated and I don't know what to do, I can rely on this variable in equation method. I'm not going to do anything different when things are super simple. I'm just going to go through this process in the same way because that consistency gives me confidence. Okay, so I just want to write down again what we have here. I have 23 miles, and that corresponds to 1 gallon of gas. I want to know how far can I go, in miles of course, on 16 gallons of gas, or said another way, how many miles of traveling will correspond to 16 gallons of gas if everything else is equal. So when it comes to ratio equations, I just need to find these pairs. One of them is what I'll call my reference pair. They need to give me some information of how these 2 units are related, 23:1. And then the pair that has one of them missing, and that's the one I want to find. So that means I'm going to say that looks like a 2. That was supposed to be a question mark. In a box, represent the number, it's always a number, of miles on, let's say, 16 gallons. Full sentence, but it doesn't have to be too wordy. Now I can use this to actually set up my ratio equation in a super easy way. It's so convenient. I'm going to erase these arrows because they are in my way. Then I'm going to make a fraction out of the first one, fraction out of the second one, put an equal sign between them. Boom, ratio equation. Now in an equation I did say that I don't love the units in there, but I want the units in the beginning to see, oh, miles, miles, gallons, gallons. Okay, it's perfect. Not that they're going to try and trick me on purpose, but if one is given in miles and the other one in kilometers, well, that's a completely different story. They have to be the same units. Now, there is another way to set this up. I don't care. This works always. There's my equation. Now I identify it as a ratio equation, which means I'm going to cross multiply. That does not mean I cross out the equal sign. It's just a reminder of what I do. 1 times question mark, well, that's just one question mark. I don't need the 1 there. 23 times 16, and I get my answer. We can do 23 times 16 if you want to. 16, not 106, 16. And we get a line, no. We get 368. Concluding sentence, it's a word problem, like always. Step 1, step 2, step 3. You get 368 miles on 16 gallons. And again, some of you might sit there thinking, oh, of course you multiply them. Duh. You know, it's surprising. What's obvious to one person is not obvious to everyone. It depends on your experience. I can totally imagine from my experience working with people that if you see something for the first time like this, it's not necessarily obvious. You see it a few times, maybe in this specific way, because I have 1 gallon of gas, and your experience, it becomes more obvious, sure. But that first time, no, I can't assume it's going to be obvious. Just because it's obvious to me, no. But now I have a systematic way of explaining it in the case where it might not be obvious for someone. I have a fallback method that if it's more complicated or it's not obvious in whatever way, or I have doubt or whatever, I go through the motions. There is no doubt anymore. It's very important to have that backup because it's not always going to be obvious. Next example, 1618. There are approximately 2 pounds of muscle for every 5 pounds of body weight. For a 90-pound person, approximately how much of the weight is muscle? Now, I don't know. Do I multiply? Do I divide? There are 3 numbers. There's a 2, there's a 5, there's a 90. I'm freaking out. I don't know. I don't have to know. Math is not, contrary to what many people think, math is not some magical thing some people can just see in their mind. The numbers are floating like in a movie and they merge together in the perfect way, revealing the answer. No, that's nonsense. I almost said something I shouldn't say. That I'll stick with nonsense. It's not how it works. It's a language to logically think and work through something. And that's what I'm going to do. I have my reference pair, 2 pounds of muscle. Now I kind of have to write, because they're both pounds, I want to know which one is referring to which. 2 pounds muscle, 5 pounds, let's just say body weight here. It's my reference pair. I want to know for a 90-pound person, so that means the weight of the person is 90 pounds, what amount of muscle corresponds to that, and I'm of course going to have it in pounds as well. So I'm setting it up, and this is always going to be the same. And that makes me feel confident every time I do it. But that tells me how I'm going to define my question mark in a box. That's my symbol. Of course, use an X, use anything you want, but define it. This was just a setup for me. Let question mark in a box represent the amount of muscle in 90-pound person. I'll squeeze it in according to the question, right? I'm sure they're averaging these things or whatever. Now I can use this setup to very easily show the ratio equation that is hiding behind this. Make a fraction, equal sign between. So 2 over question mark in a box equals 5 over 90. Can it be any easier? I don't think so, honestly. Cross multiply because it's a ratio equation. So 5 times question mark. I always put the pair with the variable on the left because it's going to be nice and presentable. Next. Then I divide both sides by 5 and I see my answer right away. It's right there. Let's do it. You can do it in your head if you want to, but why bother? It is good practice in general to try and do it in your head if the numbers are nice and then verify it with your calculator. But I just want to make sure that I get everything in our session. I think we have more than enough time, but I want to be sure. So 36. Now I have to remember, what does that mean again? Oh, it's all written down. I don't have to actually think about it. It represents the amount of muscle for a 90-pound person. So, 90-pound person has, I guess these are approximately 36 pounds of muscle. I'm sure everyone's different. This is probably some sort of average. That doesn't really matter. What matters is notice how my approach from start to finish is the same as before. I want that consistency because that is what's going to save me when I don't know, when I don't have experience to just know what to do with these numbers. I don't ever have to. If there's someone that says, well, of course it was 2 times 90 over 5. That's great for you. I wasn't sure. I needed some logical, systematic way to get me there, and I never had to worry. The way I combine these numbers were that was a result of solving the equation. I never had to know how to put them together. Plus, if I need to explain this to someone who is struggling, I can't tell them, well, you just do this and this and this and this and this, and put them together like this. No, I need something more insightful, something more systematic, something more logical that they can use, that they can build on and apply to another problem and sort of become independent in that sense. So I have multiple goals here because things do get messy eventually. 1619. I think we're going pretty fast, so I think we're good. The label on a container of concentrated weed killer gives directions to mix 3 ounces of weed killer with every 2 gallons of water. That's my reference pair. For 5 gallons of water, how many ounces of weed killer should you have? Again, great. If you have a good number sense for ratios, that is a really good skill to have. And you'll develop this skill by initially writing everything out. And then you start seeing, oh, or maybe you don't. That's okay too. So I have 2 gallons. No, not gallons. That's not the first one they said. I have 3 ounces of weed. I don't actually have to label it because the units are different. Pretty sure it's the unit for ounces. Correspond to 2 gallons of water. It's only when the units are the same that I have to have some extra description here to remember which is which. Then they say 5 gallons of water is going to correspond to how many? See, there's always one of these that are missing. How many ounces? Now I know I'm going to set my equation up from this, but the first step is the first step, and that is defining the unknown variable. It's going to represent the, I'll just say, amount of weed killer. We're not flipping units or anything like that. For 5 gallons of water. If there's no unit issue, don't make an issue out of it. Then I'm going to set this up, and you see the repetition, and that should make you feel good. It makes me feel good. You see, ooh, it's always the same. Oh yeah. So when I go into another question that has a setup like this, I'm going to be pretty confident because I always do the same thing. That consistency helps me a whole bunch. But I've seen anxiety being caused when you have a situation. Well, in some cases I do this, and in some cases I do that. And if the words are this, then I do this. No, that's not how we do it. It's not going to go well. I want to avoid that as much as possible. So I have my ratio equation right here. I never worry about, oh, is it 2 times 3 and then 5, or 3 times 5 and then 2, and what do I do? No. The ratio equation tells me what to do. By solving it, how I combine the numbers in the question comes out. And you see here, it's a result of the solving of this equation. And they're so easy, you can do these in your head. I have done it many times. Let's see, 3 times 5 is 15, over 2 is 7.5. Let's go decimal here. I've used this because it's such a simple equation. In the cross multiplication, you only keep track of 4 things. You can very, very efficiently do this in your head. Let's write our concluding sentence. What am I solving here? I forgot. It is the amount of weed killer that goes with 5 gallons of water. Okay, I didn't want to mess that up. Yeah, that's important. Get the ratios right. So with 5 gallons of water, we use 7.5 ounces of weed killer. Again, I'm emphasizing the same thing because it is so important. Oh, this one's a little, I need to zoom out a little bit, right? Zoom out just a touch, just a touch. Same process. Ooh, this one's zoom in too, wow. Not that, there we go. Same process, same process. It's that process that I can rely on when things get maybe a little complicated, and we'll sort of hint at that at the end. These examples are part of an introduction to this kind of question, to this kind of equation, and we're not going to jump in at the deep end, of course not. But we can certainly make it much more complicated. All right. I think where this really shines, in my opinion, is exchange rate questions. This was made for exchange rate questions. But we're going to start small. A car costs $20,000. Using an exchange rate of 0.64 pounds to a dollar. Now, I don't know if this is actually the exchange rate right now. I don't really care. 0.64 pounds to a dollar. What is the price of the car in pounds? That might be an important question. Whether you're a car dealer or you are traveling and looking for the best place to buy the car, whatever it is, exchange rate issues come up very frequently. So I have a $20,000 car, and that is going to correspond to, I just go with whatever the question says, right? They started with 20,000, so I started to write 20,000. But that's not my reference pair, because I want to know in pounds what is the value of that $20,000. So that's not my reference pair. I need a reference pair somewhere. Well, it says to $1 I get 0.64 pounds. That's my reference pair. It doesn't matter if it's second. I just need both. I still have my symbol, my question mark in a box variable, and that's going to represent the value of the car in pounds. Then everything is still totally fine. Get rid of these arrows so it's not too cluttered. Get out of here, arrow. Make it a fraction, equal sign in between. So 20,000 over 1 equals question mark in a box over 0.64. Solving this tells me how I need to combine the numbers in question. Now it's 1 times question mark, so I don't even need to write a 1 there, right? There's only one question mark. And the others are 20,000 times 0.64. And that then gives me my answer. Let's do it. 20,000 times 0.64. I get 12,800. Now, yes, I've met people that are business students. And of course, then they think about these kinds of things more often. And he was very adamant that he doesn't need to do this. He knows you multiply. It's 20,000 times 0.64. And he looked at me as if, what is wrong with me? I know what this is. What is wrong with you? Rather, looking at me. He's talking to me. What's wrong with you? Why can't you see that it's 20,000 times 0.64? Yes, if you do this enough, and the numbers are always sort of the same in the same presentation, given to you in the same way, then yes, you start noticing a pattern that you can repeat. Sure. But if I have never thought about exchange rates before, or I'm just not a very confident person, which I kind of am not, I need something. Whether it's exchange rates, whether it's weed killer, whether it's muscle to weight ratio, whether it's miles to a gallon, it's always the same. It doesn't matter how I combine the numbers. The solution or the solving of the ratio equation tells me how to combine them. I never ever worry about, do I multiply? Oh, but if it's presented like this, then I should divide. In that case, I multiply. I don't care. It's a waste of mental effort. The setting up of the ratio equation should be your only priority. Nothing else matters, because everything else is sort of a byproduct, a consequence of that ratio equation. And it's a waste for me to think about it. It's inefficient. When solving the equation is going to tell me the way to combine them. I never have to think about it. It's irrelevant. The equation is the only thing that matters. To a degree, of course. I'm exaggerating. I do need to clearly define the variable, of course. Last one. 1621. A laptop costs $300. Using an exchange rate of $1.24 to a euro, how much is the laptop in euros? So now some people think, oh, do I multiply? Do I combine? I don't care, honestly. I could not stress how little I care. I'm not looking for shortcuts. This is pretty short already, let's be honest here. This is the detailed version. When I do it for myself, of course, I don't have to write all this out. So it's pretty fast. So what do they say here? I have an exchange rate. Maybe you want to start with the exchange rate. $1.24 to a euro to 1. How do I write the euro? Is it like this? Afterwards? I'm pretty sure. Then, it's my reference pair. Then I have a $300 laptop, and that I want to know is how much in euros. Now, of course, some people, I do not envy teachers in school, because if you want to sort of teach any independent knowledge, skills, there are going to be students that say, why do I need to learn this? I can just ask Google. I don't even have to type it in. We have Google Home. We can just ask her. It's a different time, and it's really, technology has encouraged us to stop thinking. And that sadly has consequences beyond school performance. Just if we stop thinking, our brain never develops. What are we really? But it's so tempting. I just ask Google what this is. I don't need to think about it anymore. I don't know the answer, and how you convince someone that that's not a good idea in general. Have the skill first, and if you're lazy, sure, ask Google. But don't rely on technology completely. You have to have your own skills as well. But if little Timmy asks you that one day, I don't know what you're going to say, because nothing's going to convince him. He's already made up his mind that he doesn't need to know this. It's tough. It's really tough. Now I want to define my variable. That's pretty obvious what it is. I just want to write a sentence. It's going to represent the value or cost of the laptop in euros. Squeeze it in. Then my ratio equations right here, I never have to think about how do I figure out this number. I never give it a moment's thought. What I do pay attention to is the ratio equation, but it's super easy to set up. It doesn't matter where the variable is. I just need to know what this looks like. And then it's super easy, 4 things to keep track of in my head. Cross multiply, move on with my life. So now it's 1.24 times question mark equal to 1. I'll emphasize 1 times 300. But often in exchange rate questions, one of the numbers is a 1. I don't even have to do a calculation, which then shows that I needed to actually combine the numbers in this way in this case. So it's all a matter of which unit do I have information for? How is the exchange rate presented? Because it can be represented in 2 ways, right? It could be number of dollars to a euro, number of euros to a dollar. And depending on which one, I do a different calculation in combination with which number was presented originally. I don't care. Solving the ratio equation tells me what to do. It's never an issue. Why would I spend any energy on that? Let's calculate this. 300 divided by 1.24. Oopsie, random line. Let's just think, did I do that right? Yeah. I have to be careful to not let my rants get a little too long. Get too excited about this. I just rounded right away because this is my final answer. So the laptop is approximately worth 241.94 euros. Whoopsie, backwards. Euros, that's an S. There we go. I'll zoom out again. Oops, like that. And emphasize again. Come on, line. Same method. Same. So I can handle a whole bunch of questions as soon as ratios are involved. All depending on the ratio equation, which is a very simple equation as far as equations go. I can do these things in my head. Now you get a question like, for example, you can do so much with this. If you start looking, it's really something that is empowering. That is the word. And maybe in the grand scheme of things, in our current level of technology, you don't need it. Sure, there are many things I don't need, but they make me better. I don't need to learn how to play a musical instrument, but it does something to you on so many different levels. It's not just about playing the notes, for example. It's about experiencing things that are sort of beyond words with music. It opens so many doors. It's not always about the actual thing you are practicing. But we need to have wisdom and vision to realize that. And of course, kids don't have that. So I was thinking, for example, you're in a store. Let's suppose you want to buy some Oreos. Now they say that you get a 500 gram pack and you get a 200 gram pack. The 500 gram pack maybe costs, it's on sale, $4.50. Because it has a yellow sticker at Save-On? Is that good? Does that mean I should buy that automatically? When the 200 gram pack is maybe $2.25, which is pretty good for that size. I know because I buy Oreos all the time. It's not a good habit, but at least I'm honest about it. So now you have to think, which one's better? Which one's better? Which one should I buy? If I don't care about how many Oreos, of course I want more Oreos, but I could always double up on this one, right? Which one is better? Which one's a better dollar value? Those are important things, and it's all ratios, right? The grams to dollar ratio, you're going to pick the one which is better. Now, I'm not saying every issue, every situation, every question is exactly like this and requires a ratio equation. These are presented in a way that gives me that base, that consistency, and that awareness, starting to think about ratios. It doesn't mean that for every situation, practically, I need to come up with a ratio equation. Where's my unknown? No, there is no unknown. I can certainly make it one by making one an unknown and saying, let's find out what should a 200 gram pack cost to be perfectly in line with the 500 gram pack. And then I can compare that after the fact with how it looks compared to 225. You can do that. You can certainly make a similar question out of this. Absolutely. And then we can say, well, and I'm doing it quickly, right? Because I'm standing in the store. I'm just quickly trying to think about this. And I can't go and ask Google, which pack of Oreos is better? I can use Google as a calculator, sure. But I need to figure out what's the calculation first. There is a human element still. Now I'm doing a short way because I'm standing in the store and people are walking around me and wondering why I walked against the arrow in the aisle, and I don't want to stand there for too long. So this then says 500 times question mark will be 200 times 450. And then, of course, this guy is divided, and there's my calculation. Sure, take out your phone, do the calculation, absolutely. I'm not saying do everything in your head, but there is a human element first that I need to know how to combine these numbers. 200 times 450 divided by 500. And I just chose to make this the mystery number, right? You could have swapped this around in many ways. And I get $1.80. So if this was in line, they would have had to reduce the price of the smaller pack to 180 to be comparable. So that means the 500 gram pack is a better value. If I, of course, now ignore the fact that if I buy a small pack, I'm going to eat all of those Oreos. But if I buy the big pack, I'm probably going to eat all of those Oreos as well. So we're not thinking about the health issues here, just a straight up value per Oreo or per gram or whatever. So there are a lot of things that we can do. If we start talking about exchange rates, you think about where we are. Many people travel across the border to the States to fill up with gas. And then the situation becomes less obvious than one might think. I'm not going to do this whole one, but I'll paint the picture. So you have on the Canada side versus on the States, you travel across. So over here, I think I looked at one gas station. It's 121 per liter, and that's Canadian dollars. In the States, you just look across. I don't know what it is. Like, let's suppose, just random. I'm totally guessing. I don't know. I haven't gone there in a while. 350 per gallon. And that's, of course, a different currency as well. So now you have a bunch of units that are different. Both of the dollar units and the volume of the gas is different from the other two. So now there's a whole bunch of conversions that you need to make by way of a ratio equation to ask, well, which one is better? Which is a better value? And then you have to factor in the fact that you have to actually, it's going to cost you money to get there to then fill it up and drive back. So if one is better, it has to be significantly better to justify the extra cost and your time, which has value as well. So it becomes quite an interesting, but not a simple question. And there's a whole bunch of ratio questions in there that you can systematically do. Well, okay, if this is Canadian dollars per liter, let's figure out what this is per gallon. And then let's convert that dollar amount, Canadian dollar amount, to US dollars. So you have a bunch, sort of a chain of conversions that you need to do. And people automatically assume that, oh, well, this is usually better, so it's always better. I'm going to drive and spend my whole day to fill up, when actually the gap might not have been that great and you wasted your day. But having the skill to plan out how I'm going to figure out this, that's a little bit more complicated. And of course, you have to build up to that. But having that, what's the word? That ability for yourself, that if I really wanted to figure this out, I have the ability. I might not do it super quickly because a bunch of units are different here. I can definitely figure it out for myself and feel empowered because I have that ability to think for myself. So there's a lot of value here beyond practical means as well. And I try to think about what things are similar. Well, playing an instrument, learning to play an instrument, that's hard. And sometimes you have to do a lesson and practice and you don't want to. Or you play a piece of music for your level, you're not interested in it. You're never going to play it. But it's a stepping stone. It makes you better to get to where you want to be, to develop your abilities. You might never worry about this specific question, but all the variety, you start to see common threads, and that brain matter is growing and developing. All right. That is the end of this session.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.